the tangent line problem. So objectives of chapter 2, objective. We are going to cover find the slope of tangent line to curve at a point. Use a limit definition to find derivative of function. Understand the relationship between differentiability and continuity. All right? They have a relationship. Tangent line problem. Calculus grow out of four major problems that European mathematicians are working on during the 17th century. First one, tangent line problem. Second, velocity and acceleration problem. Third, minimum and maximum problem. The number 4, the area problem. Each problem involves the notion of a limit, and calculus can be introduced with any of the 4 problems. So calculus, the derivative problem can be tangent line problem, can be what? Velocity and acceleration problem. That's what physics people use all the time. Or we can use what? Minimum maximum problem. That's what optimization problems. Like any factories, they're always thinking about how can I make what? Maximum profit with the resources, right? The maximum and minimum problem, that's calculus problem. The area problem, that's also calculus problem. Okay, all those things is a calculus problem, the limit problem. What does it mean to say that a line is tangent to curve at a point? Okay, let's think about that. Essentially, the problem of finding a tangent line at a point P boils down to a problem finding the slope of tangent line at point P. Okay, so we have 2 points right now. All right, so I will show you examples. You can approximate this slope using a secant line through the point of tangency and second point on the curve as shown in figure 2.3. Secant line means 2 points. We have this line right here. This line is called secant line. Are you with me, class?
Yeah.
Okay, tangent line means only 1 point touches the graph. Right? Next one. So if C and f of C, does everybody understand? C is just the x, and this is what? Y, x value and y value. Are you with me, class?
Yes.
All right. If C comma f of C is a point tangency, and C plus delta x, f of C plus delta x, you can think of this as what? The way that we know x1, y1, you can think of this as what? x2, y2. Is everybody with me? Or you can think that way. It's the second point on the graph of f. The slope of the secant line through the 2 points is given by substitution into the slope formula. Did you hear that?
Yes.
Slope formula. We're using a slope formula. So slope is what? y2 minus y1, x2 minus x1. So you know what y2 is, which is this. F of what? C plus delta x minus f of C. What's x2? C plus delta x minus C. Is everybody with me? Let's just simplify that. Then C and C cancel out. Right? So what do you have now? F of what? C plus delta x minus f of C divided by what? Delta x. So the right hand side of the equation is what? Difference of quotient. This is a quotient, right? The rational function is also what called quotient. This is a numerator and denominator. This is your quotient. So it's called, you have a difference, right? Difference of quotient, just like what it is. You're subtracting each other, so difference. This function right here is called what? Quotient, so difference of quotient. And delta x is what? Change. So if this was C and this is delta x, this much is what? That's your change, isn't it? Change of x value. Is everybody with me? That's what that means. So that's why it's called change in x. And the number, the numerator, delta y, is this, or the difference. All right. So this is a picture they're showing. Look at the secant line. This is the secant line. If my delta x gets smaller and smaller and smaller, what happens now? It becomes a tangent line. Delta x used to be this much big. Let's make it smaller and smaller and smaller. What happened? Pretty much what? Nothing, almost like a 0. The change is nothing, then become a what? Tangent line. Alright, so formal definition. Definition of a tangent line with the slope m. If f is defined on an open interval containing c, and if the limit delta x approach to 0, the change of x is getting smaller and smaller and smaller. Is everybody with me? Delta y over delta x, I can rewrite it as what? Limit delta x goes to 0. F of c plus delta x minus f of c divided by delta x. Or I can do what? y2 minus y1 divided by what? x2 minus x1, that's the same thing. That's equal to what? Slope, m. Exists. Then the line passing through c and f of c with the slope m is a tangent line to graph of f at the point c of f of c. All right, so they're just giving you one example, but I want to do your example. Okay, so this is what they're asking. To find the slope of the graph, f of x equal to 2x minus 3, and c is equal to 2. So they're giving you specific c to use. They're telling you use what? X equal to 2, that's what they're saying. Are you with me, class? I'm plugging in x as a 2, that's what that means. So I'm gonna use definition. So delta x goes to 0. I'm replacing c as what? 2. The exact number that I'm gonna use, because they're only interested at x equal to what? 2. So 2 plus delta x minus f of 2 divided by delta x. So the equation says, what's my equation? Equation says 2 times what? X. Whenever I see x, I'm replaced with what? 2 plus delta x. So this is that part. Is everybody with me? So I just plug it in. So 2 times 2 is 4, 2 times this is 2 times delta x, just a minus 3. And 2 times 2 is a 4, and then you have a negative in the front, negative 4. So negative 3 and negative sign makes what? Positive 3. And you can just simply cancel them out. So you only have what? 2 delta x divided by what? Delta x. They cancel out, you have what? 2. So when delta x goes to 0, you still equal to what? 2. So they're telling you the slope at x equal to 2 of this line is equal to what? 2.